Rolls Royce started out kind of making diesel engines, and you've talked about the Merlin engine, which kind of helped Britain's successful Second World War effort with Spitfire, the Lancaster, etc., etc.
When in 1938 war clouds were gathering over the continent of Europe, the Rolls Royce factory in Derby assumed a new importance. Home of the company since its inception in 1906, it was from here that one of the United Nations' greatest contributions to victory was brought to fruition by a picked group of designers, engineers and executives under the able leadership of Sir Arthur Sitgreaves and Mr. E.W. Hydes. Inspired by the tradition handed down by the late Sir Henry Royce that only perfection was good enough, management and workers set about the task of further developing an aero engine which would enable the air forces of democracy to sweep the enemy from the skies and bomb his industries into submission. This engine was the Merlin.
The drive after the Merlin came was they maxed out how fast they could go on a diesel prop engine. So that's where the jet engine came into kind of place, which was developed independently of each other by Frank Whittle in the late 1920s and a German chap called Hans van Oheen. Both of them worked independently and came up almost with the same concept. So the Hans van Oheen, he kind of put jet engines into German Heinkels just about the Second World War, and Frank Whittle kind of started with the Welland engine and created the Gloucester Meteor. So, and then kind of after the war, they looked at how they could adapt it to civil airspace. So they kind of, in the 1950s, they developed the Dart. The Dart went on the Viscount, and the Conway went on the 707, which was 1960s. And that was a collaboration with the French, with Snecma, which were the French aviation industry. The Olympus powered Concorde, but also powered the Vulcain bomber as well. So it was used not only in civil aircraft, but it was also used on defence as well. So you had things like the Olympus 593, which was one of the kind of marks of it. Unfortunately, Concorde retired after the Paris kind of accident. And Concorde was very much a kind of niche. It's actually quite a small plane. You'd be really surprised if you ever go and visit a Concorde, how small it is. You know, there's only 100 seats on it. So it's not the huge plane that a lot of people would think. And it was very much an elite market and a prestige market, but probably not a market for mass flying of people, you know. So the Olympus, yes, it was a fighter jet engine that was adapted in conjunction working with our French partners. One of the key points in Rolls Royce history was the RB211, which initially went on the TriStar and then kind of moved over to go on to the 747. And the RB211, the RB kind of was developed in Barnoldswick. That's where the B comes from, Rolls Royce Barnoldswick. So they're very proud that it was the 211th design and iteration of the kind of engine concept that they had been working on. Lots of variations on the RB211, and eventually that became the kind of fundamental kind of shape of the Trent engine. Trent Series now, which has been Rolls Royce for the most successful series of engines that we've made right through the 1980s, 90s, 2000s. Talking about Trent 500, Trent 700, Trent 800, Trent 1000. These are all kind of big runners across kind of Boeing and Airbus. And now obviously we talk about the XWB and the Trent 1000, which the XWB is on the A350 and the Trent 1000 on the Dreamliner, and they are kind of like 60% of Rolls Royce order book going forward. They are the big engines that we're going to run with. The XWB, the most efficient engine in the world, is the tagline that goes with it. And then obviously going forward, we're now looking at taking new concept designs on these and creating engines with Ultrafan. Over the years, engines, the driver has been to try and create kind of like more fuel efficiency, lower noise, and lower emissions, NOx emissions. So we obviously want to try and develop more green-friendly kind of engines. And as we've been doing that, we're kind of looking at the technologies to make the engines kind of perform better. And that kind of involves a lot of change of architecture, change of materials, carbon fibre, kind of going on to fan blades and things like that. We're talking about kind of using lighter alloys, using alloys that go a higher temperature. We're right on the cusp now of what the capability of some of the alloys in the engine are. So we need to kind of continue to develop new alloys, and that can take 10 or 15 years for an alloy to go into service once it's completed all its long-term testing. You know, especially when you get to the back end of the turbine, effectively the turbine is operating at temperatures higher than the actual materials melt at. So they use thermal barrier coatings, they use recirculated air. So the analogy we use, it's like being able to put an ice cube in your oven in the house at 200 degrees and keep it as an ice cube. That's what we're doing at the back end of an engine. We're operating at a temperature 200 degrees hotter than the melting point of the alloys we use. That's amazing technology, isn't it? So that's kind of where we're at with respect to development of materials in engines. Ultravan is a change of architecture, it's a much wider fan, so we'll be using more bypass air to power the engine, and the advantage of the bypass air is you don't heat it, and it also can act as a kind of sound muffler, so it kind of helps to kind of keep the noise down as well. And that higher bypass kind of gives you a higher thrust for the amount of energy that you're going to do in the burn. But we still, even regardless of that, we still have got all the engines that are existing to maintain and supply spares to. So it's not that you kind of move to Ultrafan and forget about everything else. You continue to have a bigger portfolio of engines to supply spares and maintain. I think at any point there's 25,000 Rolls Royce engines on the go.
The Rolls Royce organisation may well be proud of its contribution to victory. Workers, designers, engineers, management, all fulfilled a vital role in Britain's days of need. Now they can once more turn their hands and their brains to the fulfilment of the needs of a world at peace. And this, indeed, they have done. For in October 1945, 2 months after the end of hostilities, it was a Rolls-Royce jet turbine that streaked across Britain's lowering skies to claim the world speed record of 606 miles an hour. What promises to civil aviation did this imply? What even newer principles of engine design and propulsion are now occupying the minds of the Rolls-Royce organization? For the world of science has much in store, and in the forefront of mankind's march onward will be Rolls-Royce applying to practice the newest and latest principles of scientific achievement.